attending today's webinar, Making the Case for Next Generation ROADM, sponsored by Fujitsu. Before we begin, I wanted to cover a few housekeeping items. On the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be captured, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow help widget with a question mark. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green resource list widget. Towards the end of today's presentation, we'll ask for your feedback. A survey will pop up open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available approximately 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Heavy Reading Senior Analyst Sterling Perrin. Sterling?
Thanks, Allison, and hello and welcome everyone to today's webinar, Making the Case for Next Generation ROADM, which is sponsored by Fujitsu. This is a topic that's definitely heating up as we see systems that we've been talking about for some time moving into commercial deployment, so definitely a very timely discussion. My name is Sterling Perrin, and I'm a Senior Analyst with Heavy Reading, focused on packet optical transport, and I'll be the host for today's webinar. And I'll introduce you here to our other speakers. So from Fujitsu, very happy to have joining us today Steve Pelosi, who is Vice President and Head of Optical Products, and Michael Sabelhaus, Principal of Optical Solutions. After I give my opening comments, we'll hear from both Steve and Mike, and of course they'll be available to participate in the Q&A. Just to give you a sense for the flow for the next hour, this slide shows the agenda. I'll kick things off with market drivers and benefits, and then actually hand it over to Steve to give a little bit more view on the context and kind of the broader context of how ROADMs fit into the optical market. Then we'll hand it over to Mike, and he will go through the next bullet points you see on the slide, talking about ROADM architectures, next generation ROADM applications, some other considerations as you deploy these networks, and then an interesting cost comparison analysis that Fujitsu has done. And he'll make some summary comments, and then we'll move into the Q&A. And we should have about 10 to 15 minutes for the Q&A. So as Allison indicated, please do ask those questions electronically as they come to you. We'll be gathering them out, and we definitely do keep time at the end to handle those. We also have 2 poll questions in today's webinar, which are a good way to get some thoughts from the audience in real time, and we always get interesting results from those. So those will be coming up after my portion, and then a little bit later on will be the second one. So we're talking about next generation ROADMs, and I want to just give a context of what do we mean by this. We see actually that we're moving into about the 4th generation of ROADMs since their beginning commercialization, which I've traced back to the early 2000s. I don't know if there were some commercial deployments prior to then, but definitely by 2001 we saw some stuff out there in the network. The previous generations we saw, the initial one, wavelength blocker, would be the technology that defined that generation. Then we moved to another technology choice, planar light wave circuits, or PLCs. And then we moved into the 3rd generation, which is kind of the entrenched generation we see today based on wavelength selective switches, or WSS, and that's when we really saw a boom in ROADMs in the network. The 4th generation is actually not a single technology. It's based around 4 main functions which can be used in different combinations, and I've listed out and defined the 4 functions here. We have colorless, defined as the automated assignment of an add-drop wavelength to any available physical port. Directionless, which allows any wavelength to be routed to any direction served by a node. Contentionless, which allows multiple copies of the same wavelength on a single add-drop structure without requiring engineering and partitioning type of restrictions. And we'll see diagrams and additional detail as Fujitsu goes through these. But I want to give a high-level kind of view of what we mean by the terms. So CDC, colorless, directionless, contentionless together provide an end-to-end automation at the photonic layer. This is often called zero-touch or touchless provisioning and network operation. Prior to CDC, if we look at a network, the express nodes along that route were automated by software and touchless, but the manual connecting and truck rolls were always required at the endpoints of those connections. So CDC is eliminating those endpoint touch points and truck rolls. And so those go together to enable that. The fourth definition and component of NG-ROADMs, flex spectrum or gridless. This allows for wavelength spacing beyond today's 50 gigahertz or 100 gigahertz spacing. This is a future-proofing technology to make way for channel rates beyond 100G, which are going to occupy more than 50 gigahertz of spacing. And so a different type of ROADM needs to be in place to handle that. As I stated at the very beginning, CDCF ROADMs have been talked about for a few years. In fact, going back to the Light Reading Packet Optical Conference in May 2010, Verizon was the keynote speaker there, and they gave a pretty extensive presentation on the value of these next-gen ROADMs, and that was actually my introduction to the topic at that point. But the reason we're discussing the topic today in this webinar is that a number of factors have come together that make this the time, not just for renewed interest, but actually seeing a move to wide-scale commercial adoption. I've listed out the main contributing factors to that right here. I've already talked about the fact that we've seen these ROADMs, early generation in ROADMs since the early 2000s. We're seeing a lot of RFPs out now looking for new ROADM networks, and so it's a great insertion point to put in the newest technology when you do that. Also, there were requirements for new technology, these 1x20 WSS devices. Previous generation WSS was at 1x9, so you needed these new high port count WSS devices. And initially they were expensive. We've heard about prices coming down to be more economically, and the system vendors are happy enough with the pricing that they're able to design these into their systems. The third bullet point here I'll talk about on an additional slide, but 100G coherent systems moving from long haul to metro, and basically a lot of activity around coherent 100G becomes both an enabler and a driver for moving to new ROADM networks. On the flex spectrum side, we have advanced modulation schemes and super channels, all enabled by coherent detection. And as I indicated, you need more than 50 gigahertz spacing if you do plan to put these super channels in your network. And so that leads us to these types of new ROADM deployments with flex spectrum hardware. And then last but certainly not least, the software control. This is a story of both software and hardware. The software control standards had to come up to speed and mature to actually control the hardware, and we've seen that happen, and systems vendors and operators are much more comfortable with that technology. Again, our speakers from Fujitsu will go into the detail on the architectures with specific diagrams about how these things look within the node. I wanted to provide a high-level look at each of the functions and then the key enabling technologies for those functions, and then the applications, which basically by applications here I mean what does the function enable in the photonic network. Colorless, directionless, contentionless, these three functions go together to enable different degrees of automated or the zero-touch provisioning and operation. And we'll get into detail about those different degrees and what kind of the trade-offs between the different combinations. Colorless and directionless, though, from a hardware perspective, require these twin 1x20 WSS components as well as coherent receivers. When you get into contentionless, that requires another bit of hardware to get that added flexibility, and this is a multicast or an M/N switching element which goes into the node. And then the flex spectrum was an interesting development because it required for many of the components vendors to move away from the MEMS technology, which was the foundation of many WSS components out there, to new technologies that could handle the flex spectrum, primarily liquid crystal on silicon, but not the only technology, but certainly a move away from MEMS, and that's again to get to 400G, terabit, or whatever those future bit rates will be. Wanted to make a point here about the terabit networking boom and and the need to look at ROADMs not just in isolation within the photonic network, but as part of a larger migration. And it really is driven by this migration to 100G transport, and more specifically to 100G transport based on coherent detection. The figure on the left shows heavy readings forecast for 100G line-side port shipments, and these are broken out by long-haul and metro and regional applications. We saw the 100G boom start in the long-haul network, and then most recently we're seeing that move into metro and regional deployments, but certainly the growth is tremendous in both of those segments. As you can see here on the slide, we expect a 50% compound annual growth rate for 100G in the long-haul networks and a 74% CAGR in the metro regional networks, and that actually could be a bit conservative. There's certainly some drivers that could boost that rate even above what we had in this forecast, and we may revise that in the future upward if we do revise it. As the operators migrate to 100G, as I indicated, they're reevaluating their entire optical infrastructure, layer 0 and layer 1. So they may not change the whole thing, but they certainly need to look at all of it kind of holistically. And so the move to 100G typically doesn't occur completely in isolation. And I've indicated the 4 technology evolutions that are pretty tightly interwoven. Coherent 100G and plus, meaning the beyond 100G, you have to make some assumptions how you think about beyond 100G when you're moving to 100G itself. The next generation ROADMs, the ROADM hardware, all the functions we'll talk about today. Switched OTN, this tends to be large-scale switched OTN, which is becoming a next-generation Layer 1 switching technology. And then I alluded to the software automation that's required to make these ROADMs work, and that also plays into, it's not synonymous with SDN, but certainly can relate to SDN as well. We'll talk a little bit about that when we get the Fujitsu speakers to go through their portions. My final slide, I just want to talk about at a very high level the primary benefits of moving to these CDCF ROADMs, and I've listed them out here. On the OpEx side, eliminating that manual intervention, the truck rolls from the provisioning and operation of network saves both money and time. It also reduces manual errors in the network. We heard a lot about connector problems, dirty connectors, as these things are physically plugged in and replugged. All of that, automating it, moves to OpEx savings, which are very important, of course, for network operators. On the CapEx side, there are some big savings that come from integrating your switched photonic layer with a switched OTN layer, and Fujitsu will talk through some CapEx savings analysis that they've done, which shows some pretty significant savings of that layer 0 and 1 integration. On the revenue generation side, we've got rapid service provisioning, differentiation, and ways to generate additional revenue, basically things around bandwidth on demand. And then longer-term benefits, as I indicate here, tied to IP and optical integration, some strong benefits you get from tying those 2 layers together, which often, but not exclusively, often would be done through moving to some sort of SDN software technology in the network. And so with that, what I'd like to do is pull up our first poll question and bring in the audience to weigh in. I just went through what we see as some of the high-level benefits to moving to next-generation ROADMs, so I'd like to take a moment here to see what the audience thinks about those benefits. And so if you could list out what are your primary benefits of next-generation ROADM do you see as most critical for implementation? You can select either the OpEx reduction benefits, the CapEx reduction, topology, flexibility, and simplified operations, the rapid provisioning, bandwidth on demand, ways to boost revenue, which are clearly important for some operators, or is it really around the IP and optical integration and moving to SDN? And while we wait to get a critical mass, I should note as well that this webinar is kind of a paired product from Light Reading. We are doing both the webinar and also I've authored a white paper on the same topic, which will be published very soon within the next few days. And I know in return for your participation in this webinar, everybody will receive a copy of that white paper, which goes through again additional detail in terms of what we're discussing today. Let me give another moment here, and we'll push these results out. Let me give a push here and see what's coming out. And I'll bring in Steve here at this point. Steve, if you want to just kind of weigh in, and interesting results, at least from my perspective. It looks like topology, flexibility, and simplified operations coming up top, and then a pretty close tie between the CapEx and the revenue generation, and then actually the OpEx stuff, which I spent a fair amount of time talking about. It looks like it's coming in last, at least from this audience. Any thoughts on that?
Yeah, thank you, Sterling. Actually, it's some really interesting results. I think the topology, flexibility, simplified operations, not totally surprising that was rated high. We know that the operational expense is a very large part of the expense that the carrier faces in running the network. I'd say the only thing that surprised me slightly was I would have expected the rapid services provisioning maybe to be a little bit higher, because that's sort of on the revenue generating side. But overall, some very interesting results.
Sure, there is a lot of talk these days about rapid service provisioning for sure. Why don't we? Yeah. So with that, let's keep going. Let me tee up your first slide, and you can take it away from here, Steve. Thanks.
Okay. Well, thank you, Sterling, and really thanks for laying out the background on what's happening in the industry and the market. Again, my name is Steve Pelosi, and I head the Optical Business Unit for Fujitsu Network Communications. I just want to present a few high-level introductory slides before we go into more of the technical details. Overall, from a Fujitsu perspective, we think that this next generation ROADM technology is a really big deal. We think it's going to be a cornerstone technology in the network for the next 10 or so years. And adding OTN to this flexible optical layer, we believe, provides additional benefits. What it does is it provides the carriers with the ultimate flexibility in their network. So this should hopefully, as Sterling alluded to, reduce operational expense, just improve speed of doing things, improve network utilization, and even network reliability. And certainly my company, Fujitsu, we believe in this technology, and we are investing in this heavily to bring these products to the network. The next slide is really just showing a little bit of history of the network evolution, and again, Sterling kind of touched on this, but in the late 1990s, early 2000s, we saw static ring networks, and these were followed up by what I'll call static mesh networks that were also WSS based. And starting around 2010, we started to see the introduction of dynamic mesh networks with 100G technology introduced, also OTN switching, mesh restoration, control plane, path computation elements, all kind of like these advanced features that enable the network to be more dynamic. The step that we're talking about taking next, which is really rolling out this year, is really having much more flexibility at the optical layer. And there's different ways you can implement this, but Sterling touched on colorless, directionless, gridless. Also, there's an option for contentionless. And we think we'll see different carriers moving with different implementations. And finally, there's dynamic control, so you'll also need a path computation element in this architecture, in some cases multi-layer path computation element. And then really on my last slide, it's kind of like two slides kind of combined in one. So on the top part of the slide, it's really showing the progression of the network from what we call connected, or really to me connected means we maybe had multiple service-oriented overlay type networks. You may have had things like ATM or frame relay that were certainly networks, but they were limited in their functionality. But then what we saw in the industry maybe around 8 to 10 years ago was a drive towards converged networking, meaning you try to drive towards a single network layer that can handle multiple services, multiple capabilities. So for example, SONET was an older generation converged layer, but now we're seeing OTN, IP can also serve as a converged layer. And what we're creating today is really a much more programmable network, meaning you can reconfigure functions within the network dynamically as you need to instantiate them depending on service needs and what's happening in the network. And of course, that involves the SDN and software network function virtualization and other capabilities. And then kind of the bottom part of the slide, what we're really showing, at the very bottom in the center, you kind of see like a multi-layer network with optical at the bottom. This is the CDC, CD-ROADM. And to us, that's really the cornerstone of the network that enables the flexibility. And on top of that, for further benefits, you can add an OTN layer and a packet layer, just depending on how, what the carrier deployment needs are. And this would be talking, through various types of open interfaces, and we'll talk about those interfaces a little bit more in the presentation, into the next generation CO, both at the access part or also at the core part of the network, and even national data centers that could have in their virtualized functions. And so all of this, when you combine it together, this network vision gives you an end-to-end dynamic network which enables multiple services over a multi-layer converged network. And with that, I would like to turn it over to Mike Sabelhaus, who's a principal solutions planner in the optical area at Fujitsu.
Thanks, Steve. Thanks for queuing it up here and giving us some background. And thanks, Sterling. It's a good intro. What we'd like to do now is just look at what we believe is a fork in the road. We're talking classic ROADM architectures today, particularly those based on WSSs, allow for adding, dropping, and express routing traffic through the network nodes. But, as Sterling had mentioned and Steve talked about, highly effective, being a mainstay in the optical industry, being deployed for a long time. But have these architectures actually lent themselves to being the most flexible architecture in the network? And so feedback we're hearing is, we could do better. And so what we're seeing is WSS architectures from the classic ROADM day include a single WSS, typically for each direction, with fixed wavelength assignments to specific ports, fixed direction assignments for multiplexers, and partition add-drop structures, all part of this. So as we migrate, there's a couple of architectures that have come clear. We're seeing what we call the colorless directionless with flexible grid technology, and we're also seeing a colorless directionless contentionless architecture with flexible grid architecture. And so these are two of the architectures we're viewing as being available. And what we'd like to talk about in the upcoming slides are, what applications do they both lend themselves to? What's the benefits derived from each? What costs are involved in looking at these different architectures? So moving forward here, let's take a look at the classic ROADM briefly here. So what you'll see is typically comprised of amps, one or more WSSs as we discussed, fixed MUX/DMUX units, broadcast and select type architecture where the signal coming in was broadcasted to the WSS ports, and then the optical signal sent down to the MUX/DMUX units, and likewise the signal being added would come up to a WSS and would actually be added to the mainstream. Again, drop side MUX/DMUX architecture, fixed kind of configurations. Typical configurations you saw were 2-degree east-west, which was a predominant application and deployment, although most of these came out with 8-degree architectures, so you could actually do east-west, north-south, northeast, northwest, so on and so forth. Now, one of the main features behind this classic ROADM was, as you saw, the express routes basically was very common and allowed traffic to be brought through the network and dropped appropriately. But the actual drop mechanism in this, which was the array waveguide, or in some cases could have been thin film filters or other technologies, actually had some limitations. It's typically single stage, the AWG operates like a prism, so it was kind of a fixed configuration. They were simple, relatively inexpensive, and you basically, if you wanted to change the port, you actually had to move a connection from one filter port to the next. So if we move into the CD-ROADM, what you see is it actually has a new WSS architecture, and particularly an express route. Again, you have the amplifiers. Again, these are typical configurations. You'll see the WSS could be potentially 1x9 or N by 20, could be 1 by 20. These are optimized for coherent operation. These are also new formed architectures. Unlike the broadcast and select, these actually include or have a route and select architecture. They definitely support flexible grid with either LCOS structures or MEM-based structures. In new features which are being included in from vendors like Fujitsu are intelligent in-service fiber connection verification, so that as you connect all these ports up, you can actually verify the fiber. Plus, OCM or per-channel power monitoring is included to make sure that you can monitor all the power levels in each one of the ports. Again, colorless, any wavelength can be assigned to any port. Directionless, any wavelength from any degree can connect to a shared drop side or added to either stream, east-west. Typically, configurations could be 8D or larger. Drop side amps required probably to overcome some splitter coupler losses that are probably and most likely will be included in either the WSS or the fan-out units as noted here. And so what you see the difference in the architectures going forward will be the CD and the CDC will tend to keep a similar express route architecture, but the drop side architectures will be different. And in looking at this example, the CD architecture is kind of characterized by the mid-stage WSS, which is possibly a 12x9 or could be other configuration, and a drop fan-out, what we call splitter coupler. Different than the classic, but it offers flexibility, scalability, simplicity to the operator, and enables wavelength reassignment and rerouting. That's really most critical. Okay, let's move on to then the CDC-ROADM. Again, as I mentioned, you see the same express route, the amp, the WSS main stage, provides the same functionality as CD-ROADM. Again, all the key things, the architectures, coherent operation, route and select architecture, so on and so forth, flexible grid operation. But in this case, not only colorless and directionless, but you get contentionless. So really, contentionless prevents wavelength blocking that can occur when two wavelengths of the same color actually converge on the drop side structure. So typical configurations of a CDC-ROADM would include 8D capable. We're seeing 10, 12, and 16 degrees, certainly feasible. Characterized in the CDC-ROADM as on the drop side being typically an amp array to overcome some of the MCS losses. And then literally a N by N switch, could be 8 by 16, could be other configurations that give you a multicast switch functionality that allows you to have contentionless drop side functionality. So really, CDC-ROADMs eliminates the contention issue that can be associated with a CD-ROADM. So let's talk about that briefly. So do I really need contentionless? Well, that's a good question. Contention is not only a network issue, but it's a node issue. So you'll see that network blocking can largely be eliminated by doing some intelligent routing algorithms You can evaluate the span and node wavelength constraints. You can identify optimum wavelengths for provisioning from A to Z. And obviously, using some of these algorithms has some benefits of doing simple, low-cost configurations based on these algorithms. Benefits of flexible dynamic ROADM network without blocking can be achieved potentially with contentionless. Although there's probably a point in time where a contentionless architecture may be more feasible or desirable. Much work has been done on intelligent routing algorithms to prevent blocking, and I know there's several papers out in the network, or out in the internet that support this thought. Okay, so it's worth mentioning flexible grid while we're talking the ROADMs. To date, many of the WDM networks have been designed to operate on the ITU 50 gigahertz grid pattern. This is a standard that's been in place for many years. Future next-gen ROADM networks will allow different channel sizes depending upon the wavelengths being transported and the modulation of that wavelength. You can see in the diagram in your upper right that looking at a conventional WDM, and this is based on a 50 gigahertz grid, and then comparing that to the diagram below by doing some new techniques with Nyquist WDM and potentially some new modulation schemes, and offering the next-gen ROADMs with flexible grid. You can see that the grid size can be dynamically adjusted. And in this case, we're showing 37.5 gigahertz grid spacing. And looking at a 400G signal, you're getting a 25% improvement, spectral efficiency, I should say, in the network. So while you're thinking, well, this is all fine and great, that facilitates new modulation schemes, and I deploy super channels, and the next-gen ROADMs actually offer this. There are some issues that can be associated with these different channel sizes. If you look at the grid below, you'll see that obviously deploying 100 gig and 400 gig or maybe 40 gig and 1 terabit signals, you can get some spectral inefficiencies or some straining of some bandwidth. So we believe that in speaking for some of the future things that ROADMs, next-gen ROADMs will help you evolve to and give you some benefits are some of the SDN tools that can help you defragment these spectral inefficiencies as you have churn in your network and you're deploying different amounts of bandwidth for different wavelengths. You might see that there's some bandwidth that's being stranded. In this case, with some of the new defrag algorithms and some of the tools, you can actually defrag that, much like you do a hard drive, and basically have the bandwidth and the network retune itself to free up that stranded bandwidth. We believe this is a big issue, especially in some of the metro networks. We've heard that some networks have been defragged, but not nearly enough in the metro space, especially with a lot of churn. So, Sterling, with that, maybe you can talk to the next polling question.
Yes, thanks. Thanks a lot, Mike. So we have come to our second poll question. Should be up on the screen in front of you. Question is, what type of ROADM network configuration will service providers predominantly deploy within the next 1 to 2 years? So kind of a near-term window. Classic, as Mike had described, which was kind of the pre-CDCF variants of ROADMs. Will it be colorless, directionless? The third option, CDC, colorless direction with the contentionless functions that Mike had talked through, or none of the above, no ROADM networks. So if you're a service provider, answer on behalf of your own network. If you're a supplier to the industry, if you can think about how your customers are building their networks, answer from that perspective. And let me give a moment to get enough in here. But Mike, while we're waiting, a question I've got for you. So in your options that you've listed here, I noticed that the flex spectrum is always kind of part of the mix. Are you seeing, from your customers, are you seeing that they just want that future-proofing technology no matter what, regardless of whether there's kind of any near-term plans for 400 gig or whatever? Is anybody asking for CDC without the F, for instance?
A good question. Actually, I think it's a two-pronged thing. We're seeing our customers, asking about future-proofing, and certainly this is on their minds. So we're certainly happy to provide it. But we're also seeing the component manufacturers actually, stepping up and providing components that can do this. So it's kind of a yes, we can get it, and yes, we'll implement it type feature. And so we believe customers are actively looking at it. They're actively thinking about it. We've seen some deployments around the world where people are doing trials with FlexGrid and things like this. So yes, definitely.
Okay, good. So yeah, I pushed the results out. Take a look at them. Any surprises? Looks like the colorless and the directionless, almost half, and then a quarter of them going for the CDC, the contentionless, and then kind of another quarter going for just the classic ROADM. Obviously, everybody's kind of interested in ROADMs on this call, so not many are saying no ROADMs. Any surprises that the CD's overtaking the CDCF?
Yeah, that's a little bit of a surprise to me. Be quite honest with you, I think there's a lot of discussion, around with customers and with different vendors about CD versus CDC. We've actually had quite a bit of flurry on CDC, and so showing the CDC and showing the CD as overcoming or overtaking the CDC is a little bit surprising.
Yep. Okay. Yeah. Same here. Always interesting stuff comes from those polls, though. So let's kind of move things along and move into the applications. And Mike, I'll let you take it from here.
Okay. Thanks, Sterling, and thanks for the poll question. Okay. So let's talk briefly about some apps, and so we're going to be cognizant of time here. Optical layer switching. We believe traditional 1+1 protection schemes actually utilize, a good portion or 50% of the bandwidth. One for in shared protections. Key application recovers idle protection, and typically we think can cover 15 to 20% based on using shared protection across several of the links. So this is what we believe is, one of the biggest benefits of deploying next-gen ROADMs. Actually, we don't believe there's any downside to this or considerations. It's all benefits to doing this. Going into the next application, optical layer reoptimization. Basically what this is talking about is optimizing new routes and capacities as become available. And as I mentioned before in a previous slide, being able to re-optimize the network when there's a lot of churn and you have stranded bandwidth. Obviously, periodic network re-optimization is a good thing, and basically it lends itself to not having to deploy, new equipment faster because you're better utilizing your current network. We believe there's 15 to 20% capacity recovery based on this, and with some of the software tools and the network architectures, dynamically adjust to this and do the optimization. Believe it provides and adheres to requiring less bandwidth protection, and then obviously optical layer protection is independent of whatever you're running on the network, because this is actually done with the software algorithms at the physical layer. So some considerations, though, really it depends on the architecture. Amount of service churn you have, you may not need to re-optimize your network. OTN, there are different optimizations and network protection schemes like OTN. that can meet quicker restoration times. Optical layer restoration and re-optimization, can be a little lengthier. It can take a few seconds to do versus some traditional 50 millisecond switchover. And then obviously, SDN and some of the technologies are not here yet today, being delivered this year, and phase-in approach. So that while the SDN defragmentation applications are coming, it's certainly not here yet. So let's move into maybe another application which I believe is reasonably important, which is bandwidth pre-provisioning. So this is actually deploying next-gen ROADM is one part of it. You need to actually deploy transponders and muxponders that go with it. And so wavelength assigned as additional bandwidth and services are required is easy to do when you're doing bandwidth provisioning and you've pre-deployed transponders. Basically, the operator can go from A to Z depending upon if he's got the right equipment there. So key point, increased service velocity on the benefit side. Really taking service velocity from days and weeks down to minutes to turn up a new service. We believe it's lower operational costs and reduced truck rolls. Obviously, it works best in somewhat predictable patterns. If you have all of a sudden a need at some node where you haven't pre-positioned, that could be a problem. And then return on investment actually could be most feasible on large backbone networks where it is a little more predictable. Considerations with this, obviously you have to pre-deploy some of your transponders and muxponders, and that has a definite cost to it. Resources may not be fully utilized, and client-side optical connections, you still may need a truck roll to hook those up if it's not taken care of when you're doing the bandwidth pre-provisioning. Okay, let's look at another application, and really this is one similar to previous ones, is bandwidth on demand, and this is actually possibly a competitive differentiator to carriers where you can actually set up bandwidth and sell services based on some data center interconnects or maybe a SAN backup where you're not wanting to provide a peak bandwidth dedicated, but you can just do, say, an average bandwidth and then dynamically adjust it to a peak setting. So this could be a new end-user application and could benefit users by lowering some network bandwidth costs versus having a dedicated private line. There are some considerations, though. Probably the first and foremost is making sure that from a carrier's perspective, it doesn't erode your cost based on providing that peak service. And there could be some network planning issues with this and may require some additional OSS and administrative functions. Okay, with that said, let's talk about some other ROADM considerations. First of all, you have a classic network. You're thinking about a next-gen ROADM, be it CD, be it CDC, either one. Yeah, how are you going to interwork these things? Well, obviously, looking at the bottom part of the diagram in the classic ROADM, you'll see that traditional ring and what Fujitsu's advocating, and we know that there's vendors that are doing this and not doing this, is Fujitsu's advocating a method whereby you can plug in the next generation ROADM into the existing shelf where you have your classic ROADM deployed. And then with this, you can grow your classic ROADM ring as needed and provide some new greenfield applications with your next-gen ROADM. And then traffic that needs to migrate between the rings can be a simple degree add to the next-gen ROADM from the classic ROADM. So traditional ROADM segments, we believe, can exist and fully interoperate with coherent-only CDC-type ROADMs. And the core really can be built as appropriate to provide growth, be it on the classic side or on the next-gen ROADM side. So really we believe there's a good migration point especially if you're using classic ROADMs in your network and ensuring that your provider can provide a migration path to next-gen ROADM interoperability. Another thing to think about is the actual dynamic ROADM management and control layer. So it's one thing to have the next-gen ROADM based, as we see here at the bottom of the diagram, but how do we get this guy to actually perform like a rock star, so to speak? You know, we want him to be able to dynamically, you know, bring up new services and, you know, manage this thing with a touch of a button. So network planning and control, new SDN platforms, we believe, are part of the way to go. So you'll see that having SDN controller, be it Virtua from Fujitsu or some other SDN controller, is one of the keys to bringing and migrating some of what I call the dynamic ROADM use cases into play. These are things like doing integrated planning and automated service fulfillment, things like dynamic service activation, you know, with a touch of a button, or even pre-planned. Lambda restoration, like we talked about in a previous slide, or actually doing network reoptimization, defragmentation, better utilizing your current network so that you don't have to outlay additional capital in the near term. So some things to think about there. Okay, let's talk cost. Some of the methodology here. One of the things that we wanted to look at here at Fujitsu was, you know, let's compare what's the end user's cost going to be with all this. If you look at the basic ROADM, 2-degree, 88-channel, no transponders, and let's do a first cost approach and look at the analysis for ROADM architectural differences. So primarily, if you look in the table to your right, you'll see standard ROADM with some of the traditional parts that come with it, a CD ROADM, and some of the traditional parts that we've outlined as promising to be used in our architecture, and then the CDC ROADM with its architectural differences. So we're going to look at the normalized cost here a little bit. So what we're seeing is that based on the initial CDC costs, they're probably about 3 times higher than a classic. A lot of these are due to the WSS modules and the core, and MCS switches and things like that. If you look at the diagram on your right, you'll see the bottom line being the classic ROADM with the green and the blue curves showing the CD and the CDC. Now, one thing to think about, and which is a little surprising here, is the CDC is actually a little slightly less expensive than the CD at lower channel counts. And we believe this is, you know, in the 30 or less channel counts. And a lot of this is due to the WSS modules. But obviously, if you increase higher drop channels due to increasing the number of amps, arrays, you know, this cost could go up. So it's architecture dependent and how much you drop at each side. So let's look at the rest of the story, though. True network costs really aren't just about the ROADM. It's with a deployed 100G that minimizes, some of the overall cost of the ROADM itself. Looking at the graph on the right, you'll see that adding device costs to the 100G transponders really dominates the network costs. So a relative cost difference between CDC and classic drops to about 6 to 10%. So there's a nominal difference given much more flexibility and capable based on whether you're going a CD or CDC. So really, the dominant costs are the actual transponders and muxponders. So just to summarize briefly, ROADM network architectures are becoming more flexible and dynamic. We're seeing new applications, simplified operations, a lower total cost of ownership is actually coming through with next-gen ROADM technology. And as Steve mentioned earlier, we're seeing this is going to be the mainstay of the next generation of technology going into the network. ROADM interoperability and SDN integration, key considerations for network planning, flexibility, dynamic provisioning, etc. Next-gen ROADM cost increases relative to classic ROADM are minimal, and that the whole system consideration has to be taken. And so what we believe is next-gen ROADMs will reduce costs, ease provisioning, and provide simplification of operations. So the real question then is, which is the best ROADM for you? So briefly, Fujitsu offers our 9500 platform, provides a highly available, scalable modular architecture, multi-degree ROADM functionality, supports both current and next-gen ROADMs functionality, and this year we're introducing our SDN controller. And with that, I'll turn it back to Sterling.
All right, thanks. Thanks a lot, Mike. Great presentation. And we've got a few minutes left for Q&A. We actually got quite a few questions coming in, which is great. Definitely a hot topic. Let's jump right into it. So, and Mike and Steve, so we're bringing, for the audience, we're bringing back Steve as well for the Q&A. So kind of between the two of you guys, you can take them. First question coming in about the complexity involved in moving to CDCF from a classic ROADM architecture. I know you've kind of talked through lots of the different components, but still we got a question about kind of maybe elaborating on the complexity.
Yeah, it's a very important question. So I would answer it really along two dimensions. One, there's kind of like the hardware level complexity within the network. And so, for example, when you deploy a CDC, are you going to deploy it as an overlay over your classic ROADM network, or is there some way that you can actually interoperate the new technology seamlessly with the currently deployed technology? So that's the first dimension. But the other part that I would say is equally important and maybe even more challenging has to do with the software control aspects, the whole OSS infrastructure, because as we explained earlier, originally ROADMs were fairly static devices, and now that we're putting a lot more flexibility and dynamic characteristics into those devices, the question to the carrier is, can your software control architecture easily accommodate that? What we're seeing some customers is they're actually going through major transitions in their OSS systems to migrate to CDC technology.
So let me throw in one thing too, Steve, and I think it goes back to some of the applications that kind of talks about not only the software, but pre-provisioning or pre-deploying hardware. Service providers have to determine how much cost they want to invest in their network on pre-deployed service packs out there in order to have this flexibility. So this is a consideration, I think, which was very key, very important when they make a decision when to migrate and how much to migrate to next-gen ROADM.
Good point, Mike.
Okay, great. So question, I've got some thoughts on this one as well, but I'll let you guys start it out. Question is, we talked a lot about 100G and we talk about beyond 100G. Question is, would 100G fade away soon? Is that expected? As 400G technology, is that maturing? So kind of your views on where you see 100G migrating to 400G.
Okay, let me start off. This is Mike. So one of the things we're seeing is 100G actually coming from the core and starting to migrate into the metro. And it's coming in like a, rushing in, so to speak. We believe 100G is going to be a mainstay for the next 5 to 8 years. I mean, it's taking off very quickly, but as networks become more and more robust and it's going to be, it's a very quick ramp as you were showing, but I think it's going to be a long, steady ramp over the next several years. So I think that 100G is going to be around here for a long time. 400G is going to take some time. I think some of the early adopters to some of the flex grid or the flexible grid technology and 400G, some of this and 200G applications, whether they're using super channels, it's the early adopter piece, and it's going to take some time, a number of years, to actually migrate to this technology.
Okay. Yeah, Steve, I don't know if you had anything to add to that. Certainly not necessary to add.
No, I think that was good.
Yeah, from my side, it's interesting, Mike, when you showed that the cost analysis you guys did, and when the 100G transponders were included in, how much that dominated. I really think a lot of the innovation required over the next 5 years is going to focus on bringing down that 100G transponder cost. That just made it so clear how big a factor that is, much less than a need to move to a higher bit rate, I think, in our research is showing that basically.
Well, I agree with you, Sterling. I think we're seeing the cost curve is eroding on 100G, and I think in the next few years we're going to see it come down dramatically. So.
Yep. An interesting comment, question, again, based on your analysis, and you did the analysis after we asked the question, which is kind of interesting, and the poll, but the comment question from the audience member, looks like the CDC is less expensive than the CD, which is what you showed. The question is, why does anyone need CD, especially for larger drop channels? It appears like CDC is always at parity or better than CD. I guess it's more of a comment, but is that essentially what you would be, based on your analysis, is that pretty much what you would advise your customers? Why not go straight to CDC? There's not really much value in just the CD only jump.
I actually think it's a customer's decision. We are hearing a majority of customers talking CDC-F and not CD. And so that's why the poll was a little surprising to us. You look at a number of RFPs that have come out this last year, and they've all demanded CDC. And I don't want to mislead. This was a cost analysis and an analysis based on some configurations. Not every node had some ROADM functionality not in the network. It was based on some number of drops and looking at that. And certainly, some of the CD components could be coming down, and I think potentially will be price parity over time, depending upon demand. But I do believe that CDC has been, from our standpoint, most people have voiced the rationale, and the rationale being, hey, with 100G transponders and muxponders and the cost today, CD and or CDC is such a small part of the system cost, it's negligible. I wouldn't say it's negligible, but it's minimized.
Right. No, I think your analysis showed that pretty, I would say pretty fairly. We're running out of time. Maybe get one, maybe two more questions in. For the audience, there should be a survey, as Allison had mentioned at the beginning of the call. If you could just take 1 minute to fill that out, we do value that feedback. Let's see. The question, in terms of what I had alluded to in the beginning, the first big discussions of these next-gen ROADMs, May 2010 is kind of where I put the timestamp on that. Several years have gone by. From your view, your customer interactions, what are you seeing in terms of adoption right now? Has much happened over the past couple of years? Have you seen an acceleration? Is it expected, 1 year or 2 years down the road, kind of for commercial deployment?
Okay, so I'll take a first crack at that. We're, as Mike alluded to, we're seeing a tremendous amount of interest in the last couple of years in terms of RFPs and lots of questions and interactions with customers. I think this year is the year we expect to see the start of the really large-scale kind of commercial deployment of CDC technology in the network, and we expect that. Over time, that'll be the dominant technology that carriers deploy.
Yeah, I tend to agree with that, Steve. All the cards are lining up, so to speak, with the players having a need, with vendors being able to supply equipment, and the software tools coming about. And I think Sterling hit it when he said, there's several key points to make all this come together. There's obviously the next-gen ROADMs, which we talked about. There's software automation tools. There is, once you get all these 100Gs out there, you still have a whole bunch of sub-rate services. How are you going to effectively transport those? OTN can help you with that.
Right.
And so those are the types of things, coherent networking, all key critical components that are bringing this all together. And I think taking us to the next step, which is like going to 400G, will come in time, but it's just going to migrate. But it's all depending upon these.
All right, good thoughts, and that takes us a little bit past the top of the hour, so we're going to have to close out here. But I do want to thank Fujitsu and Mike and Steve specifically for participating. And as always, thanks to the audience for joining in today. Great participation and great questions. Thank you, everybody.
Thank you, Sterling.
Thank you.
Thank the audience.